Because if I were to go like this,
oh, that's the one where
All right, everyone, we're gonna get started. So, of course, as always, welcome everyone online and in person to Space City Rocketry's General Meeting for October 26, 2021. So the agenda today, we're gonna be going over some upcoming events, weekly shout outs. We have an important update about something called Spaceport, payload challenge, also Triple E info, Gustavo's gonna be going over, our Kahoot, sub-team updates, and then our structures lesson with Haley. And at the end, and then at the end, we're gonna be having questions. So for upcoming events, so this is gonna be here. The COTS and SCR PDR is gonna be here until we actually do them. So mark your calendars for Friday, November the 19th at 7 p.m. The rooms have not yet been determined, but that's gonna be our COTS/Zenith PDR on that Friday night. And then on the Saturday afternoon, I says Friday there, I meant to say Saturday, November 20th at 2 p.m. We'll have everything SRAD for the team. And then a couple of other updates too. AIAA related, our third general meeting is Thursday, November 4th at 7:30 p.m. We're gonna be having a NASA speaker there, so you should really attend. And then there's also an alumni panel Wednesday, November 17th at 7 p.m. And then of course, we'll be sending out updates and reminders on the Discord throughout the week. So shout outs, we have a few this week. We want to give a shout out to Joao and Kurt for taking care of avionics while V was out throughout the week. I know Kurt had a great lesson on Sunday night that is down on YouTube too. You can always access it. And then our tutor from analysis for learning XS and CADing most of the MMM last week. And then also from Tala, Joaquin, Parsa, Elise, and I'm sorry if I mispronounced the name, Samiksha, for helping SR propulsion last week. All right, so we have I guess, a very important update for Spaceport 2022. So a few weeks ago, I submitted the application for us to participate in Spaceport, right? It was honestly longer than I expected, so it took me a couple of days to complete it. But we were getting information about who applied, how many teams applied, and there was 191 teams that applied this year to be part of Spaceport America Cup 2022. Out of those teams, only 150 made it, 151 made it, and 40 of them got rejected. So I just want to announce that we have officially been accepted to participate in Spaceport America Cup 2022, and we are New Mexico bound. So as I mentioned, there are 151 teams that are going to be going. Of course, not every team is going to be our sim category. So for 2022, there's going to be 22 other 30K COTS teams that are going to be competing. And in those teams, we're going to be going against UT, Rice, Princeton, and the University of Sydney. So we have some pretty interesting competition there. And let's strive for first place in that category. And I think we'll be able to do it. So that's, oh yeah, and we're also team 111 again this year, which is really exciting. All right, so now Gustavo is going to be talking a little bit more and giving you all a reminder about the payload challenge.
So just like last week, we still want to look for people who want to do the payload challenge. Like every rocket that we send off at Spaceport America, it needs to have a payload. It's a huge chunk of like the scoring and how well we do. So we're really interested in getting, some of you guys to start designing and working on it. There's a few constraints, the biggest ones being the it must fit within 10 centimeters by 10 centimeters by 30 centimeters. So it's almost like a rectangle that fits inside the rocket. It must be at least 8.8 pounds, among some other things. And those other things will be talked about at a info session that I hope to be having hopefully this Friday, but more details on that coming shortly. And some information on the teams, anywhere from like 3 to 6 people per team would be phenomenal. Like there's a lot of things that you can get from it. You can, have some design and fabrication experience. If you don't have that already with you, you can work on teamwork and communication. So you'll be working with like all the other sub teams really closely, and it's great experience to work on that. Some exposure to industry leaders and recruiters at Spaceport America. So there's been people who get jobs right off the bat at Spaceport America and stuff like that. So going out there and showing kind of what you can do, what you can design, and what you've been able to create is a phenomenal experience to have. And last but not least, there's a prize. So if you make first place with your payload, so the payload enters its own little competition, there's prize money that you can make. So 750 for the first place prize, 500 for the second place prize, and 250 for third place. And then there's a little QR code for the info session. And another thing is Tripoli memberships. So this coming year, Tripoli is going to be hosting the, I guess, like the launch operations at the competition. So a lot of things that go on, like going out, putting the rocket up on the launch pad, setting it off, and all these other things require you to follow Tripoli rules. And one of Tripoli rules is that you need to at least be L1 certified to go out to and do any launch operations. So yes, question. L1?
Yeah.
I'll get to that in a second. Remind me if I miss it. So what is Tripoli? Tripoli is the Tripoli Rocketry Association. They are in charge of, I guess, just the safety and like continuation of knowledge with everything that has to do with high-powered rocketry. And so why do we need it? I guess I kind of covered that just a second ago. With the competition, like I said, you need to have at least an L1 to go out and do any kind of launch operations. They're pretty strict about it. And so if we can get everybody L1 certified, that'd be fantastic, especially if you want to go out and be part of the actual crew that'll go out and put the rocket on the launch pad and set it off and all that stuff. So how do you get your membership? You can visit the Tripoli website. The QR code is right there. And on there, you'll sign up. It's pretty cheap for students. I think it's like $10 or something like that, if I'm not mistaken. I might be. But the membership is there. You'll sign up. I can send out more information later on the Discord. And there's also, information on how to get your certifications. So there's different certifications with Tripoli. There's L1, L2, L3. Those correspond to different powered motors. So if you want to launch something larger than like an Estes rocket that you can buy at your local hobby store, you will need a certification. And then those range from L1 to L3. L1 being like the smallest motors, I guess, anywhere from an H to an I. We can talk more about those details later. But essentially, the higher you go up, the stronger the motors you can use. Zenith and Oberon being L3 motors. Fun stuff. And you can go ahead and start getting your L1 using like the information on the website and talking to everybody, maybe with V in the hobby rocketry team. They have a lot of info on how to get certifications for L1s and that stuff, as well as just talking to anybody on the team who has some. And then last but not least, if you can fill out the Tripoli membership form, which is the QR code there on the right. That's just for me and Irvin to get a tally of who has their L1s and all that kind of stuff for going out to launch events and all that stuff later on. Thank you. Yes, another question.
For Tripoli, do we have to pay a membership every year, or is it?
Yes, it's a yearly fee.
Okay.
Any other questions? Yes.
Is that strictly for launch operation, or does that extend to recovery?
Anything that requires you to go out past the like the safety area requires you to have a certification, yes. So if you're gonna go out to the launch pad or go out to recover the rocket, you do need a certification. Yes,
As a clarification, you're saying we do need our L1 to be part of spaceport. So
yes, you do need your L1 to be part of spaceport if you plan on going. But I also think it's a fantastic experience to shoot off your L1 either way. So I hope you guys start getting your L1s. It's exciting stuff. I'll hand it back to,
So
oh, one more question. Yes.
everyone that has an L1, do they get to go? Or some people that have an L1 get to like.
So the way it's worked in the past, we still need to work out the details, is to go to spaceport, it's just gonna be the sub-team leads as well as a +1 for all that stuff. Just because if you take too many people, then it starts getting really crowded around the rocket, as well as all the other teams at the competition. It'll start being pretty hectic. So there's a limit to how many people we can take. It's somewhere around 16-ish. If you have your L1 and you're super active on the sub team, you are, I guess, first in line to go with the sub team lead.
So you can still go to spaceport, you just won't be part of like the assembly team and I guess a competition team.
Yes. Any questions? Awesome. Hand it back to you.
Okay, actually now V is gonna host the weekly Kahoot over last week's avionic lesson, so this is gonna be exciting. All right. All right, so get ready, everyone. The pen is about to load. Here we go. Take it over, V.
All right. Give you guys some time to get in here.
Oh my god, cute shirt. Where'd you get it?
Oh yeah, got it from the Hella Mega Tour.
Oh my god, what's that?
Dap, me too.
How are you expecting this Kahoot to go, V? Did you make it difficult?
I threw in some curveballs here and there, but I think it's not
Okay.
too bad. I think it should be pretty good.
Okay.
What a prize?
Want to what?
What a prize?
I'm sorry, one more time.
Where's the prize?
What's your prize? Oh, nice. I'm in here. Yo, about to win my own Kahoot.
Yo, what's
Hey, yo, wait, what? Kahoot, me too. I love you, Mood. Who else do we have in here? We have Donald. Carlos Fernando, the real AIAA.
Yeah.
Fuzzy Hen 33. Like some of these.
I like that.
I grew a pumpkin. Me too. Only on Halloween though.
Any respect for teams that you care about. No art.
Funny Squid 85. Nice. All right, looks like 30 people. That seems to be our number here. I think everyone had a chance to get in here. Anybody? See any comments? Huh?
they can join late?
Okay, they can always join late. Rude. When we're screaming Kahoot, me too. What's the first question going to be? Which of the following is not a flight computer state? Drogue, motor burnout, landed, or apogee?
Say it louder.
Pretty good, right?
Okay, it's not a bad, I like this question.
Oh, dang. Looks like I got most of you on this one. Danny H taking the lead, followed by me, followed by Bailey, followed by Adrian, followed by Kahoot. Hey, whoever's playing me better win. Avionics is the blank of the rocket. Brains, heart, control, or power?
Yes.
All of the above.
All of the above,
None
yes.
of the above.
Everything but heart, honestly.
So we're actually the mitochondria. Powerhouse of the cell. Something like that. Okay, I didn't get too many people with this one. Hey, look at me in first place again. Followed by Bailey, followed by Adrian, followed by Alex, followed by Danny H. Which of the following is not a flight computer? Telemetrum V3, Stratologger CF, Easy Flight 3.1.
Yeah. I like it.
Huh?
I like it.
That's what I get for our reading model.
Sadly, the Easy Flight 3.1 is not a real flight computer. Alex, you took my spot. What the heck, man? Followed by Adrian, followed by me, followed by Bailey, followed by Smith. Which ham radio certification is required to operate avionics? Technician, general, extra, or more plus? Personally, more plus is my favorite operation one.
Can I get a Master Chief?
Yeah, you get a Master Chief, just for you. Yeah, you only need the basic technician level. You don't need general. I'm back on top again. Nice. Followed by Adrian, followed by Smith, followed by Kahoot, followed by Christian. Which ham bands do we operate under? 2 meter, 5 meter, 10 centimeter, or 70 centimeter? It's directly on the PowerPoint. So far, every question has been copy paste something from the PowerPoint.
That's how it should be.
70 centimeter is the correct answer here. We do have a 70 centimeter, 2 meter antenna band. So the people who chose 2 meter, I can see where you got confused. I don't know where 5 came from. Looks like looks like out of the top 5, only Fuzzy Hen's got it. Nice. Which of the following is a software that we use? Flight UI, Alex Blick UI, Telemetrum UI, or Altus UI? Personally, Alex Blick UI is my favorite. I think Alex Blick makes the best UI. Ah, dang, 7 you only picked Alex Blick? What? Yeah, we do use Altus UI here. It's like I'm still in first place, followed by Adrian, followed by Smith, followed by Kahoot, followed by Funny Hens. Which of the following is not a feature on Altus UI? Live data collection, remote firing, motor ignition, or GPS information? Motor ignition is the correct answer. I see there's a split between motor fire or remote firing and GPS information. So it looks like we have Adrian taking a little streak here. And then we have Kahoot, Alex Smith, and on top we have me. What kind of antenna do we use? So we have Yagi, omnidirectional array antenna, or a lens antenna?
That one.
That one indeed. Yes, we do use a Yagi antenna here. In a sense, I feel like I could have made this one multi-answer because technically we have an omnidirectional that's built into the flight computer, but I didn't talk about this during the PowerPoint, which is the reason I went with Yagi, because that's what I talked about during the PowerPoint. So we have Adrian in the lead, followed by me, followed by Alex, followed by Kahoot, followed by Smith. How many flight computers do we use? 1, 2, 3, or 10? Personally, I use 100, but we're talking about on here. Broke people stuff.
What is that, like 100K? Like,
Yeah, no, like 500K minimum.
At least 3.
At least 3. Yeah, 2 of them is correct. I'm glad no one picked 10. I would have felt really embarrassed. So we have Adrian, followed by me, followed by Alex, followed by Kahoot, followed by Smith. What does GPIO stand for? Guided Positioning Internal Operations, Guided Purpose Internal Operations, General Precision Input Output, General Purpose Input Output. This is another copy paste directly from the Kahoot.
Which Kahoot?
Okay, technically, you get from the PowerPoint. But yes, yeah, it is general purpose input output pins. It has nothing to do with positions or any of that, or precision. So we have Adrian, followed by V, followed by Alex, followed by Smith, followed by Kahoot. What is not a reason we want GPIO pins? To complete SRAD, to compete in SRAD for spaceport, advancing our understanding of the rocket, one-off flights, help develop future rockets.
What is not a reason?
Yes, which is not a reason that we want GPIO pins. I should have specified, I should have like caps the not.
Caps, bolded, underlined.
Exactly. Yeah. Avionics doing SRAD will not allow us to compete in SRAD for spaceport. That is entirely based on the motor. Oh yeah, you know, right? Spaceport Europe, my bad. The competition that we were competing in, obviously. Adrian, followed by V, followed by Alex, followed by Smith, followed by Kahoot. Is this a multiplexer? There's an image.
Yes.
Oh, I got kicked out.
Huh?
I got kicked out.
Wait, which one are you?
That was Kahoot.
Oh no. Oh, you kind of did bad for project picking. I'm glad most of you got this. This again was an image directly from the PowerPoint. So in 3rd place, we have, drum roll please, Alex, no drum roll, I guess. In 2nd place, we have V. Hey, why'd you only get 2nd? In 1st place, our winner is Adrian.
Second week in a row, Adrian. Hey, I heard you're going for the 3P. I like the reference. All right. Let's present here. All right, so thank you again for participating on our Kahoot. Next week, we're gonna have these structures Kahoot based on today's lesson by Haley. But first, of course, as every week, sub-team updates. Yeah, get back here.
Just sat down. So as mentioned before, I wasn't here this week for avionics. I tried to ask Joao, but he couldn't make it today to present this. So this is a lot of stuff that Joao has done for me this week. Kind of went over the basics of Teensy with everyone. Started on some of the electronics basis, getting started with the Blink project. That is a available project with Teensy. It just kind of allows you to get the idea of, you know, how resistors work, how LEDs work, how those GPIO pins work. Talked about ideas and further input from members for SRAD. Obviously, we have quite a bit of work going on this year with SRAD, and I wanted to make sure that everyone had their chance to kind of pitch in what they believe would be useful information or potentially useful things to have. Got everyone downloaded with Teensy Duno as well as Altus OS. So Altus OS, if you guys remember from the Kahoot, is our way of controlling our flight computers and reading off our live data. Teensy Duno is used to program our Teensies that we use. It's kind of an Arduino add-on that allows us to compile for our boards. So we got everyone started there so we can start getting kind of picking up with developing stuff and, you know, kind of getting these electronic basics through. Started working with some example codes, like I mentioned earlier, with the Blink code and stuff like that to test LEDs and make sure those things work. And today with Kurt, we actually got some working telemetry working from the little XP you can see over there, sending over information over short distances. But ultimately, we have a lot more work on that before we are finished with that part.
Next up is structures. Haley.
All right, so over the past week, we started working on the nose cone trade study. So far, we have been able to define our criteria and define the different options we're considering for nose cones. In progress, we are currently having analysis work on determining the best choices for performance-wise for the nose cones. And then once we have that, we'll go ahead and work on the decision matrix. Last Friday, we were able to present all the MM designs everyone has come up with so far. Here's just two of them. One on the left is from the capstone team. The one on the right is Aussie's. By this Friday, we're gonna go ahead and pick 3 MMM designs. One of them being the capstones and who will perform their own FEA, but then 2 others, which we'll go ahead and give to analysis, and they'll go ahead and run the FEA on that.
Thank you, Haley. Okay, next up is 30K propulsion. I know Tala wasn't able to make it to the meeting. I think Parsa, are you here?
Yeah, I'm online.
All right, thank you.
So last week, 30K Propulsion met up with SRAD on Thursday. After a mini course on using the drill press, we started drilling some holes and tapping them where previously it was friction fitted. And on Thursday, at our meeting, we made sub teams to start a new project of making a new test stand. So this Thursday, each sub team, the configuration team, materials team, and electronics team will bring their ideas, and from there, we'll design our next test stand.
Thank you so much. Next up, analysis. Robbie, get up here, please.
Y'all did French stirring for that.
All right, hello, everyone. For analysis this week, the design team has mainly been working on the Oberon MMM FEA. We've made some really good progress on the CAD, as you can see in the big picture there. So something we've noticed with the NX software is that for those familiar with SolidWorks, you're able to, once you get to the assembly phase, put in your fasteners and screws and things like that. What we found in NX is that the assembly isn't as detailed as SolidWorks, but no worry. We found the FEMAP assembly is actually crazily detailed. If anyone's interested, I can show you what it's like, but it's literally, you can choose like what screws you want and how they're secured in what position. It's pretty crazy. And then for those who weren't able to download NX and FEMAP because of issues with Siemens, I told them to go ahead and make a rocket stability presentation, which they'll be giving at our weekly meeting on Thursday. So if you're interested, definitely come out to that. And then our validation team, with our standardizing units project, I wanted to kind of shift this to a semester-long thing. I think if we make kind of an additive list that we can just continuously add to as things pop up, it'll be better so we don't try and find everything all at once. And then our nose cone analysis, as Haley was mentioning, our open rocket simulations are complete, but we are going to talk to Dr. Franchek, a mechanical engineering professor here, about forming a mathematical model with the goal of finding the coefficient of drag for each different type of nose cone. And then last few notes, the PDR is quickly approaching. So for analysis, we'll be having our hands full for the next few weeks, especially with the MMM FEAs coming up as well. And just a shout out to all my members, I'm extremely proud of you for what you've done so far. So keep up the great work. Thank you.
Thank you, Robbie. And then recovery, Carlos is making his way up here.
So for recovery this week, well, last week we finished our 3-week onboarding process. You can see there the diploma from all the graduated members who stuck around and are now official veteran members of recovery. We also split up the sub team into 2 different crews. We have the separation crew and the landing crew. And we also finished the actual research for the CO2 systems this week, but we still need to compile it and then make a decision matrix, which we started on right before this meeting. But hopefully, I'm pretty sure next Tuesday we'll have an actual decision about which CO2 system we're going to use. And then for the landing crew, we're gonna start working on a calculator to calculate the size of the parachutes depending on different parameters of the rocket, as well as calculating the snatch force. And then next week, for both of the sub teams, we'll try to assign dates to basically all the tasks and milestones that we have planned out for the remaining of the year. But specifically, we'll try to get dates in for critical tasks for the PDR. And that's it for the recovery. Thank you.
Now, Ozzy wasn't able to make it either, so we have an SCR propulsion member presenting. Welcome, Scott.
As mentioned earlier, we made some progress on the test stand. We got about 3/4 of the holes drilled and tapped. So we thank 30K Propulsion for coming over. And we helped the capstone team again with the mold for the prototype, the hybrid motor casing that we're gonna make out of resin. And so some of the parts of the chamber were undersized, but we fixed it and got it all together. So now the bolts that you see there, they fit on the mold. And that's about it.
Thank you. As always, if you are interested in another sub-team and you'd like to learn more and get to the details of what they're working on, you're always welcome to join any of their meetings throughout the week. Ask for the slides or anything at all. So now it's rocket lesson. This week is the structure sub-team, and Haley will be going over some of the basics. So. All right, yeah, so I guess, this week is structures. Next week is gonna be analysis with Ravi, and then after that it will be recovery.
Alrighty, so the fundamentals of structures. So mostly I'll just be going over the material components that we're focusing on, and just kind of giving some context as to what exactly we do. So as far as decision making, we have to pick a nose cone. A nose cone is just pretty much the tip of our rocket. It's typically where the recovery system and the parachute is stored. There are varying shapes and sizes. I guess these are like the main 9 options that people go off of. They all have different drag options and they all perform differently at different Mach speeds. They're all determined based on different geometry. So they each have equations that just kind of decide the shape or like the curvature of the nose cone. And as an example, this is just for the power series, which there are multiple kinds of power series equations. Another thing we have to determine is airframes. So airframe seems very easy, but it requires a lot of coordination with everyone else because we have to make sure that we are able to secure the recovery system, avionics bay, payload bay, the motor, and the MMM. When it comes to considering that, we have to ensure that it withstands the thrust from launch from the motor. We are mostly looking, I guess the main options if you're going above 0.85 Mach is carbon fiber or fiberglass. If you research other materials, they will tell you that they're really great until they get up to 0.85 Mach speed. And we are definitely exceeding that. So that left us with either carbon fiber or fiberglass. And then looking more into carbon fiber, it actually blocks radio waves. So if we were to actually pursue carbon fiber, we wouldn't be able to have that section, the avionics section, be made out of carbon fiber, which just makes it all around a pain. So instead, we're just gonna do fiberglass. Okay, so fins at face value, also very easy, but there's actually a lot that has to go into it. So I guess on the right is pictured all of the different sections of the fins. So you got your root core, which is the part that's actually connected to your rocket. Then, yeah, your tip, tab, semi. So the semi-span has to be at least 1 body caliber. And since we're doing a 6-inch rocket, that'll be at least a 6-inch semi-span. And then another thing to consider is fin flutter. And then I know also Ravi last year had made like a fin flutter MATLAB thing that can be used to determine it. If like your fins will flutter or not. And they kind of look like this picture on the bottom right here. It's not supposed to look like that. So it's not like a fun, cool thing that you're supposed to aim for. Fin flutter just means that it pretty much has failed at the speed that you're going at. Yeah, they're just having a good time. And so yeah, for that equation right there, here's some of the parameters for that. The MMM is something that we've talked about a couple of weeks now, but I guess we've never fully gone into what it does, unless you're within structures. The main criteria of it is that it needs to secure the fins, it needs to secure the motor, and it needs to withstand the forces of launches and landings. But I guess on top of that, and you need to be able to manufacture it, you need to be able to secure it, it needs to be easy to assemble. Goal is for it to be lightweight. So it's a lot of considerations that we have to consider. Here's 3 designs that were presented. I want to say that there were 7 designs that were presented total on Friday. And like I said, we're going to limit it down to 3 options to take more seriously, and we'll go ahead and talk about those at the PDR. All right, that is my lesson. Short and sweet.
All right, so are there any questions about anything, PDR, competition, anyone has? Check the chat. Yes, I have a question. Yes.
When do we start writing the PDR, getting the materials for that?
So the question was, when do we start writing for the PDR? I guess it kind of depends on the sub team. I know analysis is they're doing a lot of the FEA after everything's handed by them by structures. They'll probably be doing it towards the end. But I'll say the first week of November is probably when you should start writing it. Yes, Haley.
When will we have the format for what you'll expect in the PDR?
You'll have it before the first week of November. Yeah.
Okay, by the end of this week.
So yeah, by the end of this week you'll have it.
Okay.
Yeah.
Yeah.
Any other questions? No. Wait, hold on, let me check the chat again. I kind of. Jacob Brimlinger asked, who is Ligma? I don't know. All right, I'll end it at that.
Can we watch the Astros game on here?
Can we watch the Astros game?
Yes, on here.
Who said that?
Huh?
Watch it.
You're a Cowboys fan.
All right, thank you everyone for joining, and we'll be seeing you next week.